I'm John Golia.
And I'm Greg Fife. And we are
the Flight Safety Detectives.
We're just two guys who have spent most of their career with the National Transportation Safety Board investigating aircraft disasters and aviation safety issues all over the world.
Yep, and this podcast is where we talk about everything from accidents, airplane technology, to the big business of aviation.
We live and breathe aviation. My co-host John has been in the aviation business for more than 60 years. He was the first and only airframe and power plant mechanic to get a presidential appointment to the National Transportation Safety Board.
And Greg is a former air safety investigator and GO team captain for the NTSB. He's investigated everything that flies worldwide since he started his career 40 years ago. And on top of that, he is a Living Legends of Aviation inductee.
So between John and myself, we have over 100 years of aviation safety experience. It's time to buckle up because it's going to be wheels up. Let's get this show in the air.
Hello, John. How are you doing? As a flight safety detective, still locked down because of COVID.
Without a doubt. I am. At my age, we got to stay as safe as possible.
Yeah, you are older than dirt, so yes, I can understand that. Thank you very much. But that being said, you are also very wise. So that's why we are doing this podcast together.
Yes, and a lot of people appreciate what we're doing, judging from the feedback that we're receiving. A number of people. And in fact, we recently did some of the backstories for the ValuJet accident, which seemed to hit a lot of people close to home because we had a number of comments come back in, one of which I would like to pursue today. So we had a listener request us to go through the voice recorder on ValuJet the way we went through the voice recorder on Lion Air and Ethiopian. So to go through step by step sort of what the flight data recorder means to an investigator, to you in the field, and to the person in the field it means one thing. But after you get back and after you collect all the data on scene, you go back, the voice recorder then yields much more information as you have more detail about the physical evidence and you go back to compare it to what the pilots were seeing or doing, and it actually adds considerably additional material and data to the investigation a month and 2 months into it than it did at the initial time. But initially, it is very important.
Absolutely. And that is one of the two tools on the airplane. That is the flight data recorder being the second tool. And one of the things that people think that both these black boxes, even though they are contained in an orange container, one of the big things that people believe with these flight recorders is that they are the magic bullet. That is, that they give you the answer to the cause of the crash. And that's not necessarily true. When you look at the contents of the flight data recorder, it is just recording artifacts of that particular flight. It's giving you a variety of different parameters. Some of the older flight data recorders were limited to 30 to 100 parameters, depending on how it was configured. Now we have thousands of parameters being recorded. And while this is all valuable information for the investigator, it is information that, one, has to be validated, two, has to be corroborated against other evidence, because we have seen where flight data recorders had issues and what was actually physically available on the aircraft wasn't absolutely reflected on the flight data recorder. Errant flap settings and things like that. So you can't take these things at face value. With the cockpit voice recorder, it too is basically an electronic witness, as I've always described it. It's like a third person sitting there watching things take place in the cockpit, but it is only recording the artifact. And in this particular instance, not only the conversation between the two pilots, but anybody else that is in earshot of the cockpit area microphone. These cockpit voice recorders are broken up into various channels, typically 4 channels. So you have a separate channel for the captain, a separate channel for the first officer, and then in this instance, we have a cam channel or a cockpit area microphone, and it's a microphone strategically placed in the overhead that records just the general noises and discussions that may be taking place, not only in the cockpit, but within earshot of that particular microphone. So when we look at a cockpit voice recorder, we're trying to understand what's taking place, what conversations are going on between the crew members in the cockpit and then anybody else that may be located in the cockpit, as well as any background sounds that could provide us information. We've been able to pull information about engine speeds based on background noise and electronic signatures when dissecting cockpit voice recorders and things like that. So it is a very valuable tool, but there are some issues when you read a cockpit voice recorder. The problem is in the transcript, the written transcript, there is no emotion. So it's just words on a piece of paper. While we try to put the inflection in there, whether it's a question or a statement, you can tell that by listening, and it's then transcribed with, a question mark. Like if one pilot is reading a checklist and they say shoulder harness, well, they read it in a way that they're waiting for a response. So it's projected or presented as a question, and then the next response by the appropriate person is on or checked or whatever the response should be. But because there is a lack of emotion in these words, sometimes it's very hard, unless you've actually listened to the cockpit voice recorder, to understand the context. I can give you a perfect example. You can have two pilots in there, and one pilot says to the other in a very cool, calm, flat voice, "Takeoff power, Bill." Is he asking for takeoff power? That is he asking the other pilot to push the thrust levers up to the takeoff power setting? Or is it takeoff power, Bill? Like, reduce the power right now. It all depends on those emotional inflections. And again, the written word doesn't give us that. So there is an important part that the cockpit voice recorder plays in any accident investigation. And so we as investigators depend on the box being found, hopefully being in good shape, and we have a good recording so that once it is downloaded and it is presented by the cockpit voice recorder or the recorder specialist back to the investigator, they're giving us sufficient information, both from the discussion and possibly unique background noises, that can help facilitate the investigative process. And that's how it worked with this ValuJet accident. As you and I talked, John, in a previous podcast where we were talking about the fact that this airplane had an in-flight fire. And when the initial information we got during the launch sequence for the GO team was, we knew we had an in-flight fire because the first officer reported to Miami Air Traffic Control that they had smoke in the cabin and smoke in the cockpit. They didn't talk about the gravity of the fire, how bad it was, or anything else. They just wanted an immediate return to the airport. And then they were provided assistance by Air Traffic Control to make that happen. But it wasn't until we got the cockpit voice recorder that we could put all of this information in context as to what the generation of the smoke and the fire was, the gravity of how severe it was, and then later on, the fact that the airplane, the pilots were experiencing control issues, and then finally, the fact that we believe that both crew members, as well as other folks in the back, had succumbed to the toxic fumes from the fire that had occurred. So I know that you and I have a copy of this transcript, and so I'd like to walk through it with you, just because there are some valuable key pieces that as investigators, when we got this information, really directed and redirected parts of the investigation.
Before we go forward with that, there's a couple other comments that came in along the same vein of going over the voice recorders, and one of them dealt with the flight data recorder itself. And the question that was asked was, which one do we consider more valuable, the voice recorder or the flight data recorder? A lot of that answer depends upon the timing when it's going to be used, but I'll let you answer that one, and I have another comment to make about that at the end.
Well, they both have equal status in an investigation, but as I said, the cockpit voice recorder tells us how the crew is interacting with each other to handle whatever situation has evolved, whether they are cool, calm, and collected, whether they are in dire straits, whether they are effectively communicating. That's only part of it. And then, of course, any background information. Where we see a lot of importance in the cockpit voice recorder versus the flight data recorder is in some of the recent events in the past where we've had airplanes shot down, where they can actually hear the missile explosion or some sort of explosion right before one or both of the boxes stops operating. So there are these recorded artifacts where sometimes the cockpit voice recorder becomes the more valuable tool. When you look at the flight data recorder, again, it's recording artifacts of the motion of the aircraft and the operation of aircraft systems. And so it doesn't have a lot of feedback other than at this point in time in space, the ailerons, one was positioned at 13 degrees up, the other aileron was positioned at 10 degrees down. It doesn't tell you why. It doesn't tell you how. It just tells you that at that point, that's what was occurring with that particular system. There are, again, cases where when you dissect all of the performance or the parameters of a flight data recorder, that helps put the storyline together with regard to if the pilots got into a high-speed dive, such as when we did the American Eagle ATR 72 that iced up in Roselawn, Indiana. The flight data recorder was very effective in telling us that, in fact, there was ice building up in front of the ailerons. The autopilot had been engaged in that particular portion of the flight, but the ailerons were starting to move on their own from aerodynamic disruption because of the ice buildup. You could see that on the flight data recorder. You could deduce from that it was being transmitted back into the control yoke, but because the pilots didn't have their hands on the yoke, because the autopilot was engaged, they weren't getting that very critical feedback. So in this particular instance, the flight data recorder was a more valuable tool as to when the initiating factor of eventual loss of control took place. And that's really what we used to generate the basis for safety recommendations that eventually became the basis for changes in aircraft certification and the way we operate airplanes in winter icing conditions. Is that if you're in a turboprop airplane flying in known icing conditions, do not turn the autopilot on, actually hand fly the airplane so you get that tactile feedback. So depending on the nature and the circumstance, one or both boxes have an equal importance, but in some cases, one or the other provides more information to the investigators.
Yeah, you know what, and we'll cover this in a different podcast, but that lesson about the autopilot was short-lived because 20 years later, Kogan Air in Buffalo, flying on the autopilot, airplane iced up, and essentially the same thing happened again. But we'll cover that later. One of the other questions that was part of the string that came in that got us onto this voice recorder asked about why we don't get the cockpit flight data recorder information in the beginning as well. What most people don't realize is that after the airplane leaves the factory, most airlines change the software that runs the flight data recorder to whatever version software that they have. And since today, with these digital recorders, they're all zeros and ones, you have to know what the string of zeros and ones means. And sometimes it doesn't mean what the manufacturer had in their original program. So it takes us longer to get information out of the flight data recorder than it does to get the voice recorder. So, and when I did the Midwest accident in Charlotte, we were into the second day when we got a raw read of the flight data recorder information, and we proceeded with it, but some of it wasn't accurate for that very reason, because there were tweaks made by the manufacturer so that it would fit their equipment that they read it on, because they may have multiple types of airplanes and they want to have one software program that can handle all the recorders. So there's a lot of variables in there. That's sometimes why it takes so long for the flight data recorder information to get digested. And also, let's not forget that the voice recorder information, when you get it, is essentially raw data, and it can be refined.
Correct. Yeah, absolutely. And I think that see, as an investigator being out in the field, when we recover the cockpit voice recorder, we get it back to the engineering lab in DC, and they then immediately have a special protocol. In this particular instance with ValuJet, because the recorders were both underwater, they had been submerged, there is a special process that the engineers will use to recover information on the old tape machines. Now they've gone to solid state, but on the old tape machines, you had to have a proper drying process, or you could mess up that Mylar tape that recorded the conversations. And, eons ago, when they were recording data on foil tape for the flight data recorder, there was a special process to recover that foil tape so that you didn't introduce or damage any of the recorded information. Now that everything is solid state, it's kind of like throwing your laptop in the water. I mean, you can still operate it at some point, but you have to dry it out properly. I mean, that's why everybody gets all concerned every time they drop their phone in the water, because sometimes the phone won't work anymore. But you can still recover data on non-volatile memory, whether you have to remove it and put it on a slave board, whereas you take the memory chip, you actually remove it from the recorder and then put it into an exemplar or slave unit and then replay it. So there are processes that do take time so that we do not damage or lose any of that data. If the airplane is involved with the post-crash fire, there are proper procedures, because even though the boxes are technically protected to an extent, we have had charred boxes where the recording medium has been damaged, yet the engineers, through processes, are able to recover some, if not all, of that data. So that in and of itself is upfront time consuming. But then what we get out in the field initially is, like you said, John, the raw data. That is, here's some information to give you guys an idea of critical points along the flight, or critical things that were happening, or things that the crew was talking about with the operation of the airplane, that you can use to focus the structures, systems, power plant group chairman to be looking at. Or you can give this information to the operations group so that they can start ferreting out why the crew was following these procedures and not other procedures and things like that. And, as we get more information and we can feed it back to the engineers, they can also refine the data on the flight data recorder and the cockpit voice recorder so that we have the best information based on the best evidence.
Okay, so let's take this from the gate. The voice recorder printout that we have starts on the gate with the airplane preparing for takeoff. We don't have any of the sounds or recordings because the recorder doesn't start until you prepare to start the engine. So in this case, at 1340, the recording picks up, and it goes through a normal start checklist for the next 2 minutes.
So the crew is going through, and again, because this recorder has multiple channels, in this particular instance, one of the channels was identified as PA3, which was the third channel, but it was recording the PA announcements being made by the flight attendants in the back. So that's how the recording starts. You hear the PA announcement by the flight attendant. the pre-takeoff, check your seatbelts and use the mask and all of that kind of stuff. Meanwhile, the crew, their conversation is now being recorded as well, where it's obvious that they are reading a checklist with a challenge and response. So the captain is calling for certain items, first officer is responding. They are going through their particular responsibilities to ensure that the airplane is ready for flight.
All right. And as they're going through their responsibilities, they're also starting the engines, and they're calling out all the parameters for the engines, with the oil pressure and N1. They're acknowledging that all these systems are working as they should. So as an investigator, that tells you at engine start that everything appeared to be normal.
And one interesting thing, John, is that at 13:42, now the time on this particular transcript is in local time, but we use a 24-hour clock. So 13:42 is actually 1:42 in the afternoon. At 13:42:02, the specialist recorded sound of increasing frequency similar to generator increasing in RPM. So this is one of those background sounds or electronic frequencies that's being recorded where you can hear it or see it in the playback. That is very critical. In this particular instance, it's identifying that a mechanical device, in this case it's a generator, is coming up to speed or coming to speed with an increase in RPM.
Yes, and that was also heard across all the microphones. So that's another little device that we have to tell what's going on, because you have the area microphone that's going to pick up the sounds, but you're also going to be able to compare it to the two other microphones, the captains and the first officers. And that in itself can give you some clues.
And on top of that, not only do you have inter-cockpit discussion going on, that is between the two pilots and, of course, the bleed from the flight attendants, the PA, but now you also have the recorded conversation that one or both pilots may be having with air traffic control or even a ground person plugged into the airplane with regard to responding to communication. In this particular instance, one of the pilots, in this case it's the first officer, is responding to communications from a ground person. And in this case, it is the air traffic controller, ground operations or air traffic control, that's asking them if they're ready to go or taxi to the runway. And then they get talking about whether or not they're going to have a ground stop just because of issues in Atlanta where they were eventually heading.
Okay, and at 13:42, again, 47 seconds into 13:42, the ground person, the person on the headset on the ground, people see that if they're at the airport all the time, he's asking the captain to set the brakes. And having done that job for many years myself, the whole purpose there is to make sure that the brakes are set before you pull the chocks, because the engines are running. Some of these airplanes will roll pretty good on idle power. 727 was a particularly bad airplane for that, because if the brakes weren't set and the engines were running at idle, it would move at a pretty good clip. So in this case, the person on the ground is reminding the captain, asking the captain to set the brakes.
And that's also goes for when they get pushed back off the gate by a tug and they're going to separate the tug from the airplane. They want to make sure that the brakes are set so they can pull the tug, get it out of the way before any kind of movement occurs with the airplane.
Yes.
So the transcript then continues with the discussions that you would expect the two crew members to be having, and that is they're finishing up their checklist items, the challenge and response. They're finalizing the airplane and its configuration as far as fuel tanks, air conditioning, and hydraulics and things like that, prior to them getting ready to head towards the runway.
So as an accident investigator, as you go down through these lists, and I was just going to read a few of them. All right, so they talk about putting the anti-collision light on, air conditioning on, fuel boost pumps on, But one of the items is fuel quantity. So right off the bat, as an investigator, you say they at least checked their fuel load. You believe they had whatever ultimately were going to get that load, whatever was supposed to be on board, they checked to make sure they had it on board. So that sort of puts fuel starvation, if there was an engine problem, further back in the queue for possible failure modes.
And one of the other things is to ensure that the crew is doing what they are required to do from an operational discipline standpoint. One of the things that we've heard, and this was very evident in an accident in your area, John, involving a Gulfstream business jet, where the cockpit voice recorder, of course, recorded the conversation between the two pilots, but they never ran a checklist. And that became a key focal point in that investigation, because by not doing the checklist, they never released the flight control gust locks, which are locks that the crew will engage when the airplane is sitting so that the flight controls don't flap around in the wind, or if another airplane is taxiing by and happens to have a high thrust setting, it doesn't cause the flight controls to move errantly because you can damage them. So it's important from the operations standpoint that we listen to this conversation. So it's obvious that they went through the checklist. And like you said, it's obvious that they checked their fuel load to corroborate that against what their dispatch fuel load would be. So they were good to go with fuel as well.
Okay, so after they run through all their checklist items, and
they're also reading their clearance back as to what flight path they're going to fly. They were told by ATC that they were going to take off, and then they were going to join what's called the WINCO, W-I-N-C-O transition. These are specific departure routes that are established by the FAA that the pilots will follow. They were cleared to follow this WINCO transition and then get on course heading to Atlanta. It's a prescribed route. It's kind of like giving somebody instructions. Okay, when you get on the highway, I want you to follow highway, 70. I want you to be on I-70 for 10 miles. And then at 10 miles, you're going to see this exit, get on that. So that's exactly what these folks are doing. They've read that back. So now they are basically prepared themselves and the aircraft for flight.
yes.
Exterior light. Servo control. Engine start.
Now, one of the other things, John, that's interesting to note, some airlines do it. Some airlines don't. Some pilots do it. Some pilots don't. In this particular instance, they did a single engine taxi. And if you got a 2-engine airplane, you're trying to save gas. And in this particular instance, they decided that they were going to taxi out single engine. Really, it saves gas, doesn't have any adverse effect on the operation of the airplane on the ground. It's just a fuel-saving effort while they're taxiing, especially if they know that there's a daisy chain of other airplanes. That is, there's multiple airplanes ahead of them in the queue for takeoff. They don't want to be sitting there just burning gas. They can still run all the aircraft systems or the required systems on single engine, but it is a fuel-saving effort.
Yeah, and they've actually were told that they were to expect a hold, so that they knew that they weren't going to go for an immediate takeoff. They were going to be held up for some reason. Doesn't say in the recording here.
Correct. And then, of course, they continue on with not only setting the airplane configuration, that is, putting the flaps down at a particular setting, but then they're determining all of their required speeds, their rejected takeoff speed, their rotation or takeoff speed, and then their climb speeds while they're getting on course. They set the trim, which is basically a secondary flight control for these primary flight controls, such as the elevators or the rudder or the aileron, which allows them to reduce the aerodynamic forces on the flight controls as the airspeed increases, because those flight control forces get very heavy aerodynamically. So that helps in allowing the pilot to control the airplane. They finish their checklist items with regard to the configuration of the airplane. They then are sitting and waiting for several minutes while they're getting ready to take off. And at one point at 13:47:16, they are told, the captain says, when we're about number 3 for takeoff, we'll start number 2. That is, we'll start the next engine. So right there, that tells us, and we can corroborate that with other evidence from air traffic control, that there were a bunch of airplanes in front of them waiting for takeoff. So they're in this daisy chain of airplanes sitting there for quite a bit of time while they're waiting for these other airplanes to take off. And then the captain tells the first officer, okay, when we're getting close, when we're number 3 to take off, we'll get the number 2 started and then go from there.
Okay, well, buried in the middle of all this checklist items and all the rest of it is another piece of information that's important to the investigation. And in this case, it was the captain saying, it's my takeoff. At 13:46:55, the captain says that she is going to be the pilot in command.
Well, she's going to be the pilot on the controls. She's always the pilot in command, but in this particular instance, she's going to actually be the flying pilot.
Right. So that tells you as the investigator who was flying the airplane.
Correct, because in an airline operation, or typically 2 pilot operations, the crew will switch that duty. On this particular instance, she's flying. Had this flight been successful and then they were going on to another flight, the first officer would have probably flown the next leg. They alternate that. So on this particular flight, she was going to be the flying pilot. That is, she was going to be operating or manipulating the flight controls. The first officer was going to be the pilot monitoring and then performing non-flying duties, if you will.
Okay, and as we suspected, as we get into 13:48, they're taxied into position and they're told to hold.
And again, there's some idle chatter there. Now, one of the issues that always comes up, John, and we see it, you talk about it all the time, is there's what's called the sterile cockpit rule. That is that below 10,000 feet, including being on the ground, during the course of operating the aircraft, getting it prepared for takeoff, that pilots should basically restrict their discussion to operational discussions only. They shouldn't be chit-chatting about the family or the restaurant they just ate at, or the fact that they just went to a party. They want these flight crew members to restrict their conversation to and focus on that particular flight. And while that's easily said, it's not always easy, especially when you're sitting in a daisy chain and you know that you're going to be waiting for a while. There's only so much. You've done the checklist. You've prepared the airplane. You're looking out the window. You see all these other airplanes. And there was some idle chatter going on between the pilots. They were talking about some of the other airplanes that were in front of them, some of the airlines. They were talking about the fact that they didn't see any business jet aircraft. They just saw airline aircraft and that kind of stuff. So we as investigators can be very critical sometimes. Now, where it played with regard to non-essential conversation was getting back to an accident that you and I will discuss on a future podcast, and that is the Continental Express accident up in Buffalo. Those folks were taxiing out. They too were in a bit of a daisy chain, but their conversations had nothing to do with flying, other than the fact that the first officer had told the captain she had never flown in ice, because all of her flying, a lot of it was done in Arizona. And the fact that she was texting on her telephone, not paying attention to anything other than what she was texting, which was against that policy for sterile cockpit and things like that. So there are points in time when that kind of discussion or communication or lack thereof factors into the sequence of events of an accident. In this particular instance, while it wasn't excessive and it was just idle discussion, it didn't distract them from the job at hand. They were getting ready as they were moving up in the daisy chain, getting ready to take off. Okay.
All right. In fact, they even had some issues in the back of the airplane with a woman in a bathroom. Right. But eventually they were moved into position where they knew they were going to be soon given takeoff clearance. So 13:56, after about a 7-minute hold, they decided to start their engine because they could see the line getting shorter and shorter, and they knew that they were going to be called upon to depart pretty soon.
In that engine restart, again, they're going back and having to run checklist items. And again, for the investigator, we want to know if they're following all the policies and procedures that are required of them, or they're trying to shortcut the process. And in this instance, it was evident as they went through the checklist items that, of course, they were following the proper protocols when they started the number 2 engine, preparing the airplane for takeoff.
Okay. They finish it. They reset the altimeters at 1400 or so. They're complaining about some of the other airliners in the queue and how they're delaying things. But at 14:02 and 30 seconds, they're cleared for takeoff.
That time was key for us eventually because they had been sitting for quite a long time, which wasn't really a big issue. But when you look at the entire sequence of events, starting at 14:02 when they were given their takeoff clearance to the time the airplane crashed into the Everglades, that was very key as far as the total time the airplane was in flight.
All right, so 14:03, they push the power up, and away they go.
Yep, they're given their takeoff clearance. They're told to fly the runway heading. They're departing on runway 9 left. They acknowledge that. Well, as I call it when I fly, I call it lights, camera, action. That is, they turn on all the lights on the aircraft. The camera is the transponder, so they've got everything going. And then action is they're bringing the power up to their proper takeoff power, making sure that everything is in the green as far as engine parameters, hydraulics, everything else, and that the airplane is set to fly.
Okay, so now he's in the air, and he's going through the checklist again, because right after you take off, there's a number of items. Everybody will initially recognize the sounds of the landing gear coming up, but there's also slats and making sure the slats are retracted and the flaps are coming up. So there's all sorts of tasks that the crew has to accomplish, and they're calling them out according to it's a memory item according to the checklist. They just go down one after the other, and essentially clean up the airplane for flight.
And I'm just going to interject, John, that, again, when you listen to the cockpit voice recorder, you're hearing not only their discussion, but you're hearing these background sounds, as John was mentioning. So we hear the stabilizer trim in motion. That is, as the pilot is flying the aircraft, she's retrimming the airplane to relieve some of those aerodynamic forces. As the speed increases, they're on a climb out. They reset the power to climb power. It's checked. And of course, now they're following another aircraft ahead of them, which they're talking about while they're transitioning on their departure transition. They're finalizing some of the headings and speeds for the airplane. And then we had a sound of what they call the altitude alerter. That is, so when the pilots are cleared to take off, they may have an initial altitude that they're cleared to. So climb and maintain 6,000, expect 10,000 after departure, or 20, or whatever they're going to do. So they set that into a little alerter. And when they start approaching that particular target altitude, it alerts them that they typically have between 800 and 1,000 feet to go before they hit their target altitude. So that system has a tone to it. And that too was recorded on the CVR. So it's capable of capturing a lot of background sounds and noises and tones, which in some cases is confirmation. And in some cases, it's critical to the sequence of events of a probable cause.
Okay. Now this flight's continuing without any real issues, and they're talking to air traffic control and getting their altitudes and directions, headings to go. And
they held the passengers down. One of the questions that came up between the crew was, do we want to allow the passengers to get up? And, anybody that flies, that typically they wait through 10,000 feet or whatever before or they get to cruise altitude or some intermediate altitude where they believe it's safe for the passengers to get up and use the restroom, things like that. They get into that discussion, but they were going to hold them down because they were afraid of some turbulence. And we all know anybody that flies in the area over the state of Florida in spring and summertime, you have those thunderstorm buildups. You know that there's going to be turbulence, and you sure don't want people walking around in the aisles getting bounced around because of turbulence.
Yes. But now at 14:10, we've got a problem.
Here is another key time. So the airplane actually broke ground at around 14:03 in several seconds. At 14:10, there is an issue. So 7 minutes after that airplane was in flight is where this accident sequence really starts to fester. Now, at the very end of this investigation, we knew that the sequence of events actually was backed up during the course of the airplane taxiing, but we won't get to that until we finish dissecting the CVR.
Okay. So that the captain asks, what was that? And the first officer says, I don't know.
Now, and let's clarify that what they heard was a sound, and it was described as, quote, a chirp heard on the cockpit area microphone channel with a simultaneous beep on the public address and interphone channel. Those are sounds that aren't normal during the normal course of business. I mean, it's something that got at least the captain's attention enough to ask the first officer, what was that? Because that's something that we don't normally hear. And the first officer responded, I don't know. Well, of course, that prompted the captain to start looking around. One thing about pilots, it's kind of like getting in your car. You've driven your car so much, you know what it typically sounds like, you know how it typically acts. But now all of a sudden, you hear a strange noise that comes through the radio, or you're driving along, you don't have the radio on, but you hear a thumping noise or a whining noise coming from the back end of your car, which isn't normal. That cues your attention to, I got to check that. What is that? And you start questioning it. Well, that's what they were starting to do. And of course, the captain is trying to identify what the source of that noise was. And several seconds after she asked that comment to the first officer, she asked that question, she identified, we got some electrical problem. Those are her exact words. The first officer identifies, yeah. The first officer then says, that battery charger's kicking in. Ooh, we gotta. And then the captain says, we're losing everything. Now, what she is talking about is there is some sort of electrical issue. They still don't know they have any kind of problem in the forward cargo hold involving a fire. All they know is they have some sort of electrical problem that is causing them to possibly lose all of the electrical systems on the aircraft. And that is their initial mindset. And so they start dealing with that by having a discussion, the captain saying, we need to go back to Miami. And it was 1 second after she made that comment to the first officer that on the cam channel, that is that speaker that's located in the middle of the cockpit, the cam picked up the sounds of passengers shouting in the passenger cabin. Some unknown person recorded on the cam channel is yelling, fire, 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 fire. And it is attributed to a female voice, presumably the flight attendant, but it could never be determined for sure. And then another unidentified person is yelling, we're on fire, we're on fire. Those were critical moments for us as investigators, because during the initial notification, we knew that eventually there was some discussion of smoke in the cabin, smoke in the cockpit. You can have a smoke event without having a fire event. We didn't know that there was actually a fire on board. All we knew is that these folks were coming back to the airport because of some sort of smoke event. And in fact, John, we get the dailies from all over the world, aviation information. There is a smoke event or an odor event of some sort happening just about every single day on multiple airplanes around the world. So that's not necessarily an unusual event the way it was portrayed. But the cockpit voice recorder was able to shed light that it was more than just a smoke event.
Yes, and it's coming quick for these poor folks, for this crew. There's hardly a second that passes that they don't have something else going on.
And when you look at the gravity of the situation, and that's what's important to investigators, is that you look at the timing of all of these events taking place, and they're happening back to back to back to back, which doesn't allow the crew to spend any particular amount of time trying to troubleshoot one particular system or address one particular problem. Things are happening at a very rapid rate. And oh, by the way, they still have to try and fly this airplane and try and get it back to Miami in one piece.
In fact, inside of 10 seconds, the captain says we need to go back to Miami. And then 10 seconds later, she needs an immediate return to Miami. So the situation has gone from a problem that needs to make them return to something of major significance that they need to return immediately.
And when we look at that, we're looking at whether this is just an issue or how rapidly the issue has escalated to a threatening situation. And in this case, it became a very prominent threat to the crew and the safety of the airplane in a very short period of time.
Good morning, you're on the ground, Canadian 920. We're just coming up to Alpha Juliet.
First officer gets on the radio to Miami and says, we need an immediate return to come back to Miami. The air traffic controller responds, gives him both a heading and a new altitude to descend to. First officer reads it back. And then, of course, the air traffic controller asks, what kind of problem are you having? And the first officer responds, smoke in the cockpit, smoke in the cabin. He doesn't really know at that point, or if he does, he's not going to give it away over an open frequency exactly what's going on. All he needed to do was say, we got smoke in the cabin, smoke in the cockpit. That's why we're coming back. They didn't declare an emergency at that point. That was one of those discussion points that we had internally as to whether or not the crew should have declared an emergency at that point. By using that word emergency, that would have given them a higher level of priority and primacy to get back to the airport, because now you have an air traffic controller who is giving basically his or her undivided attention to your situation to work with you. So that became a discussion point in-house of whether or not they should have used that magic phrase of, we've got an emergency.
Yes. Okay, so as the sound continues, we have the voices of flight attendants talking to the crew. Obviously, they came up and they're talking about the fire in the back and the need for oxygen, obviously, because people couldn't breathe.
Here's a couple of things. There were several times with air traffic control that they hear the sound of the cockpit door moving, which means somebody's trying to get in or somebody's actually up against that door, because that's enough, and it's in close proximity to the cockpit area microphone for you to hear that door making noise. There are chimes going off with the cabin service interphone, and it's the flight attendant in the back saying, okay, we need oxygen. We can't get oxygen back there. Now, that is a key statement as well, because there was an in-flight fire. There was a fire in the back. It's now known that there was a fire in the back because people are yelling, fire, fire, fire. The premise for her to have said, okay, we need oxygen. We can't get oxygen back there. You don't want oxygen back there, because if you drop those oxygen masks and they start producing oxygen, what's that going to do to the fire? It's going to feed the fire. And so And as John and I have talked about with the oxygen masks that are on aircraft, one of the things that masks do, yes, they do produce a limited amount of oxygen. But even if you were to put that on your face, because you draw in ambient air through the sides of the mask, you're going to be breathing in that smoke anyway. It's not like the pressure breathing sealed mask that a flight crew would have up front.
Yeah, it's only designed for the passengers to get from altitude down to 10,000 feet. So if you had a depressurization at altitude, the captain would nose the airplane over immediately and get down below 10,000 feet so that he wouldn't need the pressurization for the people to survive. And the oxygen is only meant to last long enough to get you from 35 or 40,000 feet back down to 10,000 feet.
This is where this situation, based on the conversations, and they're very limited conversations, there are a couple things going on here. One, besides the flight attendant talking about the fact that we can't get oxygen back here, we should have oxygen back here. That fire, the crew doesn't know the extent of the fire. All they know is that they're on fire, or at least they've been made aware of it by people yelling they're on fire. The flight attendant has alluded to the fact that there's a fire back there. We need oxygen and that kind of stuff. Meanwhile, the crew is still trying to fly this airplane. The captain is just trying to descend the airplane to the prescribed altitude that they were given, and the first officer is trying to respond to it. Meanwhile, there's still pandemonium going on in the back of the airplane. They're trying to deal with the flight attendant who's, asking to get oxygen back there. Is there a way we can test them or whatever? It's obvious she's becoming overcome by smoke because she's clearing her throat. All of this is being recorded on the cockpit voice recorder and transcribed for the purpose of accident investigation. And again, you hear passengers shouting. The flight attendant has made a statement now to the crew, completely on fire. Now, what that means and the gravity is can only be, guesstimated as to what the crew may have thought because of that. But this statement is completely on fire. That, to me, if you hear just those words, that means you've got a raging fire in the back. You've got a very, very serious situation.
Yes. And boy, inside the last 3 minutes of this flight were fast and furious with information coming into the cockpit. They probably couldn't even comprehend all the information that was coming their way just because the speed of it, the sounds from the passengers, the screaming and shouting from the passengers, the flight attendants trying to give the captain the briefing of what they see and believe. It's just coming fast and furious for these poor guys.
A couple of other subtle things that were taking place is when you compare the cockpit voice recorder in this whole discussion from where it starts at 1410, you take the information off the flight data recorder and you're looking at what's going on with the airplane at that particular time. And when you marry up the cockpit voice recorder with the flight data recorder, it's evident that there is some control issues that are developing. And this was what gave us at least an idea that the fire in the forward cargo hold had grown to such an extent that it breached the containment of the Class D cargo hold. And the flight controls for the airplane run right over the top of that cargo hold through what's called a tunnel. And it was evident because there were maneuvers with the airplane that weren't being induced by the captain who was flying the airplane. It was pitching up and pitching down and rolling left and right, which when you compare that to the control column, the airplane flight controls were doing that on their own. And so that started to give us an indication that this fire had grown to such an extent that it was now having an adverse effect on the controllability of the airplane while they're dealing with issues in the airplane with the onboard fire.
And then only a short time later, the airplane was lost with everybody on board.
Again, another key point here, John, as you recall, is that there was a lot of discussion. There was a lot of, and I'll call it pandemonium, because when you listen to the cockpit voice recorder, it was pandemonium. People are yelling fire. And there's just, you can hear a lot of folks in close proximity to the cockpit, passengers, flight attendant, the fact that they're trying to likely get away from the area of the fire that had breached the floor in the forward portion of the airplane. You hear all of this going on. The crew is still trying to talk to each other. Now, one of the discussion points and criticisms was the fact that we don't believe that the crew put on their supplemental oxygen when this smoke event, which eventually became a fire event, erupted. And there was a lot of discussion about the fact that because the crew didn't do that, they succumbed to the toxicity of the smoke that was being generated, because shortly after all of this discussion, and all of this pandemonium is going on basically for about 2 minutes, is the fact that all of a sudden all of that discussion ceases. That is, you no longer hear people. You no longer hear the shouting. You no longer hear the crew talking to each other. All you hear is, as it was described, the sound similar to louder rushing air. And we attribute that sound to the aircraft as it was increasing in speed in a high-speed descent. There was no crew communication. They're not talking to each other. They're not making radio transmissions. You don't hear anybody in the back. And it is presumed that people had succumbed to the toxic smoke that was being generated, and including the crew, which led to this loss of control and catastrophic accident. And that in and of itself was chilling, because there were expectations that if the crew was still in command or still capable of functioning, that they would have been talking to each other, trying to figure out what to do, how to remedy the situation, how to regain control or attain control of the airplane, things like that. And it was deadly silent except for the increased aerodynamic noise of the airplane descending before it impacted the Everglades.
Yes, it's very painful to listen to flight recorders sometimes, and this one was very painful to listen to.
But in using this cockpit voice recorder, it gave us a timeline. It demonstrated how fast this situation escalated from just to a threat to flight safety. And then when it was married up against the flight data recorder, we were able to put a very good timeline together. Now, one of the things that wasn't initially identified on the cockpit voice recorder, but we could see data on the flight data recorder, was that one of the parameters that's recorded, if you remember this, John, was there was a spike in the pedostatic system.
Yes.
There was an increase, there was a big bump at just an arbitrary point, which then went back to nominal. And we didn't understand what may have caused that. We didn't know if that was just errant information in the data or what. But there was a tire being carried in the forward cargo hold that was still inflated, which should have been deflated, but it was still inflated. And that the oxygen generators that were being carried as cargo were stacked on top of the tire. Oxygen generators ended up firing off in the cargo hold. The fire, of course, erupted. There was not only baggage back there, but there was also U.S. mail being carried. So you had a lot of fuel for the fire. And as the fire grew, it breached the tire. And when the tire blew out, because it instantaneously pressurized that compartment momentarily with the blowout, that's what caused the spike on the pedostatic system parameter of the flight data recorder. So we were able to use that timing event to determine when the tire failed. And again, all of these things meant something in the big picture for putting together the sequence of events. And what we're able to determine was that we didn't think that the fire erupted after takeoff and was capable of burning the airplane out of the sky in those 2, 3, 4 minutes. We believe that most likely something occurred while the airplane was still on the ground. As the airplane was taxiing, it jostled those boxes, possibly fired off one of the oxygen generators, which over that period of time while they were on the ground was starting to grow. And that once the airplane got airborne, the fire eventually broke out because of spontaneous combustion of the cardboard boxes and that kind of stuff. And that's really when the fire event took place. But in the whole grand scheme of things, that airplane wasn't airborne very long. And it was a very fast burning fire. We did our post-crash testing and determined that it was a very hot burning fire, which led to the rapid degradation of airplane control, and then, of course, the fatalities that occurred from the accident.
Yes, most people don't realize that if you look at a welding torch that they use, and you see it in movies and you see it around construction sites with that big flame, that's a mixture of oxygen and acetylene. And the acetylene alone doesn't make a great flame. But pour oxygen into it, meter oxygen into that flame, and it becomes a 2,000 plus degree flame that melts steel. So in this case, the oxygen was just treacherous for this airplane, just a real killer.
Yeah, we had 144 basic, little blowtorches down there, because when the fire breached the floor, it was well over 1,200 degrees, because we found melted seat structure, and all that seat structure is aluminum. So we know that the fire was at least 1,200 degrees coming up through the floor and melting those seats and things like that. And there's some steel structure in that as well. So it was a very hot burning fire. It was a very rapid growing fire, which incapacitated the aircraft and the folks on board.
Yes, I remember the testing that you and I had done as part of this investigation up at the FAA Burn Center with Gus Sarkos, and we actually were able to reach temperatures above 3,000 degrees. And the reason why I say above 3,000 is the thermocouple they had only went as high as 3,000, and we pegged it out.
And not only did we peg it out, we burned it up.
Yeah, and I thought Gus was nervous. He thought we were going to burn down his test center.
Yeah,
because there was no putting that fire out.
Yeah. So that's one of the ways that, as an investigator, we use the information on a cockpit voice recorder. It is valuable, but it is a recorder of fact or artifact of what was transpiring. We're not only looking at crew performance, but we're also using it as a tool to determine what types of issues the crew may be dealing with. We know in later generation airplanes, current generation airplanes, that is, where I think the famous words that we heard when the 757 down in Cali, Colombia, where the crew is talking, they're trying to go into Cali at night, they put in the wrong waypoint into their flight management system, and of course it presented a flight path that was behind them, and the famous words were, "What the hell is it doing now?" Because that's what caught the crew's attention, that it didn't make sense since they could see Cali out in front of the airplane, yet the system is telling them, their flight management system is telling them, you got to turn around and go back the other way. Well, that was key to the investigators determining that one of the crew members had inputted the wrong waypoint, or the identifier for the waypoint, which happened to be behind them rather than in front of them.
Yeah, another tragedy.
Yeah.
I hope our listeners enjoyed this breakdown of the voice recorder and what it meant to the on-scene portion of the investigation. It would be poured over the next few months by the investigators back in Washington as they married up every single detail they could with the events that happened on the voice recorder. So you'll marry up all the information you have from air traffic control, from the airplane recorder, the flight recorder, any other information that you might be able to acquire, and you would marry them all together with a timeline very similar to the flight voice recorder timeline, so that you could get a feeling and an understanding of events as they were occurring and what happened, even though the crew didn't understand them because they didn't have any information. But as investigators, we would pull that all together and it would give us some indications of what happened, when it happened, and possibly even why it happened.
Yeah, and I think that for the listeners, we really appreciate the feedback and asking us to talk about this. That's the really the good thing. The feedback that we're getting from listeners is they want to know more, and John and I will be happy to talk more. We always do. We're very good at talking, but we appreciate your feedback. This is the kind of thing that we want to address because you give us those ideas as to what we should talk about in amongst all the other things that John and I tend to opine on a daily basis. So thank you very much for that feedback. You can always present us with your feedback at our email at flightsafetydetectives with an S on the end at gmail.com. We always appreciate comments, good, bad, or indifferent. John and I are going to address very specifically some emails that we've gotten in the recent past about some of our podcasts and try and clarify for those listeners who did respond some of the misinformation or misunderstanding that they may have had with regard to some of the comments that we made in some of these previous podcasts. So we're going to address that because I think it's very valuable to clear the air, if you will. Somebody had written in and said that we had made some statements and that we were doing it for entertainment and for the show and to excite the audience and that kind of stuff. John and I don't do that with this podcast. We don't have to do that with this podcast. So I want to address that particular email so that we can clarify. The purpose of our podcast is to present you, the listener, with as much information about aviation and aviation safety from our perspective. And while we do inject our opinions, we try to stay as factual as possible. Don't take my word for it. Here are the facts. We just try to present them in such a way that are understandable because we do have a number of listeners that we've recently found out who have no understanding of aviation but enjoy our show because they learn from our show on not only these catastrophic accidents, but aviation safety as a whole because they do fly as passengers. So again, we appreciate the feedback. We want to keep it coming. We want you to tell your friends about it. Our listenership is growing, and we really appreciate that. And again, if there are any things that in aviation safety you want us to talk about, John and I will be happy to talk about it. So with that, John, I will leave you with the last word.
One thing I would like to say to everybody is that we appreciate your listenership, and we also would appreciate anyone that can help sponsor the program so that we can continue it and take it to an even higher level than what we have already. So if you can find a way to contribute, we would appreciate that. But more importantly, for everybody out there, please be safe in your own personal life, given the challenging times we live in right now. And if you do fly, please pay attention and fly safe.
To listen to more episodes of the show, go to flightsafetydetectives.com or the Professional Aviation Maintenance Association at PAMA.org, and wherever you find your favorite podcasts. Catch us next time when John Golia and Greg Fife talk about all things aviation. Thanks for listening.